Okay.
So 8.
So, solving systems of equations. Now we're going to do it by elimination. The best way to do these is just examples, same way we've been doing all of our linear equations. But let's do a quick review of what linear equations are. What's a system of linear equations? Yeah, what? What is a system of linear equations? Josh. Yeah, it's more than one linear equation put on the same graph. So here we have two separate linear equations. If we consider them at the same time, they become a system of linear equations. To solve them, what point are we looking for? Where they intersect. Yeah, so for solving a system of linear equations, we're trying to figure out where they cross each other. If they don't cross each other, they have they're parallel lines. They have the same slope, different y-intercepts. If there's only one solution, what do they have? Yeah, they could be perpendicular. It just means they have a different slope. If you have two lines that are right on top of each other, how many solutions are there? An infinite number of solutions. So two lines that land exactly on each other, meaning they have the same slope and the same y-intercept, have infinite solutions. Okay, let's solve this one. Previously, we've learned how to solve them using graphing, and we've also learned how to solve them with substitution. Now we're going to do it with elimination. The first thing we got to do is make the coefficients on a variable equal. So you want the same number of x's and the same number of y's. Right now, do we have the same number of x's and the same number of y's? You only need to do it for one variable. It doesn't have to be both. We don't do it. 7y and 7y are close. It's a negative 7y. That's a positive 7y. Would that make a difference? Yeah, it would make a difference. We want the exact same. How can we make that negative 7 a positive 7? We can just put it on the other side, or we can just multiply everything by negative 1. Right? So if we multiply everything by negative 1, this turns into negative 3x plus 7y equals negative 2. We've multiplied everything by negative 1 just to switch that 7 to be a positive 7. Okay. Now you've done what you wanted. You've got one variable with the exact same coefficient. And these steps might seem weird, but you're going to see why we did that. Now that they're the exact same, we want to subtract the two equations. Okay, right, rewrite it over here. So we have equation 1, 2x plus 7y is equal to 13. The second equation is negative 3x plus 7y is equal to negative 2. Since our variables are the exact same, we want to subtract the two. We're going to subtract this equation by that. So what's 2x minus negative 3x? 5x. Minus a negative is a positive. So you got 5x. 7y minus 7y. 0. 13 minus negative 2. 15. And the reason why we wanted that 7y to be the exact same is so when we subtracted, it went away. Our y's are now gone. Now we just have 5x is equal to 15. And that's easy to solve. So what's x equal to? 3. If you had left it as negative 7y. So if the signs had been different, you could have just added the two equations. I like to make them so they're always the same. That way I can always do subtraction. Aaron.
So if they're already the same, you don't have to do anything?
Exactly. Just subtract them.
X is the same for
You want the x's to be different. That's good. Because then it gives you an x value that you're going to have equal to something. If they're the same, then you would get 0 plus 0 is equal to 0, which would be a problem, right? Yeah. So that wouldn't tell us anything. Josh?
Y equals and you just function you calculated?
Yeah, that would also work. But when I give you a test question that says solve the linear equations by elimination, and you put did it in my calculator, I'm going to write didn't ask for that. Finally, we have x equals 3, but we need a y value 2, so what do? Substitute, yeah, substitute x equals 3 into here. So it's 2 times 3 plus 7 times y is equal to 13. 2 times 3 is 6. Flip that to the other side, and you've got 7 is equal to 7. So y is equal to 7. Which means y is equal to 1. Minus 6 should give you 7. 7y is equal to 7. Y is equal to 1. So the point that solves this all is 3, 1. Any questions? Josh? Okay. Any other questions? Solve the following equations by elimination. 2x, 2x. They're already the same, so we're already happy. We don't have to do anything but just subtract the equations. Minus sign, big equals sign underneath them. What's 2x minus 2x? What's 6y minus 3y? 3y. What's 6 minus 4.5? 1.5. If you solve for y, you should get that y is equal to what? .5 divided by 3. So this 3 came underneath. Divide both sides by 3. Where that came from. Or it's just equal to 0.5. Punch that 0.5 into one of these by substitution, like Dawson told us, and you got 2 times 0.5 plus 6y equal to 6. Oh, sorry, I have to correct. Which just means 2x plus 3 equal to 6. 2x equal to 3. And x equal to 3 over 2. Or 1.5. There. There's 3. 6 times 0.5 equal to 3. We could solve the question below using the same method, but I think what I want to do we'll skip forward. The next one we'll do one more by practice. Then we'll do the next two by different methods. So both by using elimination. Elimination means you're subtracting the various equations. Should we subtract these equations right now? No. What do we need to do, Ella? Yeah, we have to get one of the x's or the y's to be the same. Which one do we want to make the same? Doesn't matter. You can just choose one. You want to make the x's the same? Okay. How do you make the x's the same? There. You get plus 2x to the 3, but the problem is if I go plus 2x on this side, I'd also have to plus 2x on that side. So that would work. So to figure out missing variables, you can add. What did it do, Mom? You could, pardon? You could multiply this one by 0.6. If we do that, then what's 3 times 0.6? 3 times 0.6. So this y right here, what would that turn into? It would turn into a weird decimal, right? So that, if it would work, you can multiply by 0.6, it would work, but it's going to give us a variable, or it's going to give us a decimal that's just going to make things confusing. Emma? Yeah. Times the first one by 3 and the second one by 5. Why did you pick those numbers, Ella? Yeah, because then they'll both get you to 15. So if you take this variable and multiply this whole thing by it, and then you choose this variable, multiply this whole thing by it, you'll see that you'll get a common multiple. So let's try it so you can see what it looks like. We multiply this entire side by 3, because that's what was in front of the x for the other one. So it becomes 15x plus 9y is equal to 9. On the other side, we multiply everything by 5, because that's what was on the x on the other equation. So it becomes 15x minus 35y is equal to, what's 81 times 5? 162. What is it? 405. Now, we've got 15x and 15x. Maya's suggestion of multiplying it by 0.6 would also work perfectly. You get the same answers. If you like working with decimals and fractions, then that's fine. If that makes you uncomfortable and you prefer working with whole numbers, do it that way. Your numbers might be bigger, but they'll always be whole numbers. Okay. Yeah.
Where did you put 6 again?
Well, you tell us, where do you have 0.6 from? Yeah, so she just recognized that if she did 5 times 0.6, it would give her 3. Oh, another way of figuring it out is if you took this number, the 3, and divided it by 5, that would give you 0.6. And that would tell you what you want to multiply the other one by. It's just mainly a math recognition thing. Okay, now that we have 15x and 15x, what do we have to do, Dawson? Subtract. We have to subtract one equation by another. We have to take one equation and subtract the other. So minus 15x minus 35y equals 405. What's 15x minus 15x, Johnny? $15x minus 15x? 0. What's 9y minus negative 35y? 44y. What's 9 minus 405? You're close. Yeah. 390 what? Yeah, negative 396. How do you figure out y? Keith, what do we gotta do to get y by itself? Close. We don't want to subtract. We want to get rid of this 44. How do we get rid of a 44 off of something? Yeah, which is that magic term? Division. So I divide both sides by 44. Meaning y is equal to what? Negative 9? Beautiful. But we're not done yet. Aaron, what do we have to do now?
You gotta plug it into one of the equations.
Yeah, you have to plug y equals negative 9 into one of the other equations.
So 5x plus negative 9 equals 3.
I'll answer questions when people stop being so disrespectful to other people talking in the room. Aaron.
So you plug it into like one of the equations.
Yeah, so you have to take this negative 9 and you need to plug it into one of these two equations. You can pick whichever one you want. Aaron, you pick the first one?
Yeah.
Okay, so it becomes 5x plus 3 times negative 9 is equal to 3. So then 5x minus 27 is equal to 3. So 5x is equal to 30. So x is equal to 6. Meaning that your intersection is at 6, negative 9. That would be your solution. And
If you plug it into the other one, it's still the same answer.
yeah, it would. Because that point is the only point that's similar on both lines. It's where they cross. Any other questions? The next slide is just kind of a bonus slide. Solve it using substitution. Solve it using a graphing calculator. You can do those for extra practice if you are inclined to. Joey asked another bathroom. Okay.